Welcome, applied calculators. In this screencast, we take a look at something called the Net Change Theorem. Now, it's a fancy theorem, and it says the following. It says that the new value of a changing quantity equals the initial value plus the integral of the rate of change. Now, what does that really mean? What that really means is that integrating a rate of change, yields a net difference. And that's an important piece to realize. It yields a net difference. Why does that matter? Well, I'll try to show by way of example. Suppose the population of small city changes at p prime of t is 9t squared minus 12t plus 24 people per year. In the year 2000, which is going to correspond to time equals 0, the population was, 12,234. What is the population in 2021, which is the year when this video was recorded? So what are we doing? We're given information about a rate of change in people per year. If we integrate that rate of change, P prime of t is measured in people per year. Time is measured in years. This gives us a number of people. What does that mean? If we integrate from a particular year to a particular year, this integral will give us the net change in the number of people. If this integral turns out to be 40, that will mean there were 40 more people in 2021 than there were in the year 2000. Whatever this number is, it will represent the net change in the number of people from 2000 to 2021. So how do we find this integral? Well, this is the integral from 0 to 21 of 9t squared minus 12t plus 24 dt. And how do we find that? Well, the fundamental theorem of calculus says we take an antiderivative, substitute, and subtract. Antiderivative here, 3t cubed minus 6t squared plus 24t, right? Not too bad. I don't have to substitute for you. This is arithmetic at this point. We end up with 25,641. What does that mean? That means that, so let's annotate, this is the net change in the population, which means there were 25,641 more people in 2021 than there were in 2000. So the population in 2021 is whatever it was in 2000 plus that net change, whatever that turns out to be, 37,875 people. That's the population in 2021. This is the net change theorem. You're given some change function, and it's your job to use an integral to talk about how that quantity is changing. So let's imagine that there is a marginal profit function for a particular company, and we know what marginal profit is. It's P prime for making X whatever they are, and let's imagine that that marginal profit function is 0.003x squared minus, I don't know, 0.02x plus 5, whatever. And we know that if we sell 100 items, that profit would be, I don't know, $400. So how much more profit if we increase to 120 items? How much more profit? So this is a rate of change. We want to know the net change. This is a net change in profit, which means we want to integrate P prime from what we know about to what we don't know about. This will tell us how much more profit we get if we increase from 100 to 120. Well, we'll need some sort of antiderivative on this. Some sort of antiderivative on this. Some sort of antiderivative on this. Evaluated between 100 and 120. So we would substitute the 120, substitute the 100, and subtract the answers. I don't have to do that for you. That's arithmetic. But suffice it to say that the answer is $784, which means if we increased our production from 100 to 120, we would make more money. We would make $784 more in profit if we increased our production in that way. Okay, net change says there's some derivative. We want to know how the quantity itself changes from a specific time to a specific time, or from a specific point to a specific point, and we use the integral to do that. I hope that these shed light on what you read, and we'll see you when you come to class having read and watched. Hopefully this makes sense.